Can't use my computer with this up, so it's fine.
Oh, good.
Oh, good.
Only one we're missing is Dimitri.
Yep.
All right, hello everyone. Thanks for joining us for May CocoaHeads. We're going to get underway in just a few minutes. I had to change the YouTube link, so I'll just give a few more minutes for the rest of the people to join. But we'll be getting started in a few minutes. So. All right, hello and welcome all. It's time to get started now. So welcome to CocoaHeads, Sydney CocoaHeads for May 2020. Just a reminder that we've got discussions going on Slack tonight. So the URL to join the Slack group is on the slide that you should be able to see at the moment. Feel free to jump in there, have any discussions. There's also the YouTube comments. They got a bit of activity last time, but I think primarily the discussion will be in Slack. Yeah, cool. So to begin with, I'd like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to the elders, both past and present. A little bit of housekeeping to begin with. So I'm Zach. Nikki is also hosting. Hey, Nikki, he's on the call. Nikki doesn't want to talk.
Oh, I was muted. Hi, everyone.
Classic Zoom. And Carl is also on the call. So myself,
hey,
Carl and Nikki all run CocoaHeads, and we're here to help tonight. And yeah, hopefully things go smoothly. A big thank you to our sponsors, as always. So to Biloo, to Academy, and to Atlassian for making CocoaHeads possible. They help with our costs and make these events possible, which is really awesome. So thank you to all three sponsors. A reminder that Sydney CocoaHeads has a code of conduct. We might not be meeting in person at the moment, but the code of conduct still very much applies. we want everybody who attends CocoaHeads, be that in person or virtually like we are at the moment, to feel welcome and comfortable at our meetups, and also in our Slack group, and also in any Zoom calls that we might have as part of the CocoaHeads family. We want everyone to be respectful, to be inclusive, and to be aware of other people. So you can read sorry about that. You can read the full code of conduct on our website there. The link is on the slide. And if you feel like there's any violations of the code of conduct, or you'd like to discuss any issues that might have arisen, please speak to myself, Carl, or Nikki, and we'll happily take any feedback and suggestions on board, as well as address any issues if there are any. Hopefully there are none, but yeah, feel free to reach out if you need to get in touch about something code of conduct related. So I mentioned before that we have a Slack community. It's not only used on nights like tonight, it's used throughout the month as well. Just it's a good place to hang out. I've got a bunch of developers in there, not just from Sydney. Everyone's welcome to join. It's a good place to ask questions if you've got Swift questions or anything specific. And it's just a bit of a fun community that you can participate in throughout the month, as well as on nights like tonight to participate in discussions during the meetup. So normally when we meet in person, we welcome all first-time attendees, and this is that really awkward part where I'd ask them to stand up. But in this case, it's a bit difficult. So just a general welcome to everyone who's attending CocoaHeads for the first time, and an extra special welcome to those who might not be in Sydney, because that's one of the cool parts about hosting this meetup remotely, is that you don't have to be in Sydney to attend. So welcome all. Again, normally we highlight events at CocoaHeads and any upcoming meetups or developer groups, conferences, things like that. They're a bit few and far between this year, but there's still a few that we can highlight. The first is DevWorld, which is probably the best iOS developer conference in Australia. It typically runs in Melbourne when it's being run in person in about August or September every year. They've announced that they're going online this year. So there's not too much detail yet, but we know that DevWorld will still run and it'll be online. So keep an eye on their Twitter page for more information about DevWorld. Also want to shout out the Melbourne CocoaHeads meetup, which is just as awesome as the Sydney one. And it's run on the second Thursday of the month, as opposed to the third Thursday like Sydney CocoaHeads is. So if you enjoy Sydney CocoaHeads, you're bound to love Melbourne CocoaHeads too. I'd strongly recommend checking out their meetup page and attending that meetup, especially while it's running virtually. I've attended the last couple of months and it's been really awesome. The other event that we have, which again is not in person, is WWDC. I won't go into too much detail here because I think Nikki will in the month in review, but that's happening in about a month. So we've all got that to look forward to from the comfort of our own home. It's probably the cheapest WWDC that any of us will ever attend. So that's cool. All right, so onto the schedule for tonight. Typically, one of the awesome things about, again, in-person meetups is the hiring and firing section, where if you're either looking for work or if you are looking to fill a role, you can sort of stand up in the room at Atlassian and say, hey, I'm looking for work, or hey, I'm hiring. Unfortunately, we can't really do that easily remotely, but we still want anyone who might be looking for work or is hiring to share that information. So on the Slack group that I've mentioned before, there's a jobs channel, and feel free to post in there if you have any news related to jobs, and people who are looking or people who are looking to hire will join and chime in the discussion there. So feel free to do that. We've got a couple of really awesome security focused talks tonight. The first one is by Richard Nelson, and it's all about reverse engineering the COVIDSafe app, which has been in a lot of headlines lately. So I think this is going to be a good talk. And yeah, we're very much looking forward to what Richard has to say. And then our second talk by Dimitri, called Avoiding Damage, Shame and Regrets, Data Protection for Mobile Architectures. So a couple of really great talks on security coming up. I'm sure everyone will enjoy them. And then following that, we're going to have a post-meetup Zoom catch-up, just a really informal catch-up if you feel like jumping in and having a Zoom call with some fellow developers. I'll be posting the link to that Zoom call on Slack at the conclusion of CocoaHeads. I do just ask that you please don't post that link publicly. Please don't post it on Twitter or especially in the YouTube comment section, because I know people like to scrape the web for Zoom links. So we'll just try and keep it to the CocoaHeads Slack. Thank you. And finally, I just want to mention June CocoaHeads. So it's falling at a really awkward time. As you know, we do CocoaHeads on the third Thursday of every month. That's actually the Thursday just before WWDC. So it'll sort of be the height of excitement and speculation. And we're looking for talks for June. So if you're interested in giving a talk, you can head to our website. The link is there and fill out the submit a talk form. Alternatively, just get in touch with myself, Carl, or Nikki. If you have an idea, but maybe it isn't fully ready to be a talk yet, feel free to get in touch with one of us and we'll sort of help you workshop the idea and get a talk ready. And alternatively, if you don't want to give a full-length talk, but are interested in giving the month in review, get in touch with one of us and we can make that happen. All right, so that's all. Let's begin with the month in review by Nikki. Over to you, Nikki. I'll stop sharing my screen.
Hello, everyone. Let me just set up my screen real quickly.
Cool.
There we go. Is this all working?
Looks good.
All right. Hello, everyone. My name is Nikki, and welcome to this month's CocoaHeads Month in Review. So Zach already touched on it. It is WWDC month next month, and this time it's going to be a fully global, all online dub. That's obviously going to be very interesting. I'm actually looking forward into how this will work. Are we going to have all the sessions live? Is it going to be keynote and then recorded sessions? And also, is there going to be a replacement for the labs? That's definitely something I'm hoping for. Because
so many
the labs,
unanswered questions, hey.
Yeah, the labs were always the interesting time.
Yeah.
So yeah,
a lot more fun lining up for this one.
Yeah.
Sorry.
Yeah. PJs and yeah, it's great.
Cool. And if you were to want to participate in the Swift Student Challenge for Dub 2020, that's too late. So they're closed now. So it's if you wanted to do that, too bad. If you did, please let us know. It would be fun to know who actually did apply. If there's someone in Australia that did apply for it. Cool. Moving on. Stocks. This is actually a slide that I had from October, and I thought it was funny while I was editing the month in review for this month. The stocks have changed a lot. I think back in October I said, "Hey, let's all invest in Apple right now because they're gonna jump up." And back then it was at close to 35. It's actually 313 right now. So if we all had followed my advice back then, we'd all be rich. I didn't myself, so there's that. Zach, did you do?
Oh, of course not.
So sad. Yeah. In other news, so the COVIDSafe app was released just after the last month's CocoaHeads. We'll have more on that later with Richard as he deep dives into this app. But yeah, I myself, I haven't installed it yet. I was waiting on the source code. That source code has been released. So I'll probably just check it out and see what goes on in there. What about you guys?
I'm not convinced any of us are worthy of commenting on it after watching Richard's deep dive and how interesting and deep he's gone into it. So yeah.
One thing we have noticed is that it plays havoc with the entry passes at work. So if you've got an app that uses Bluetooth to get through doors, you've got to kill the COVIDSafe app to be able to get through the door.
Unsurprising.
Wow.
Yeah.
You must know similar things too, Zach.
Yeah, I've heard of similar things with a lot of medical sensors, like particularly continuous glucose monitors for diabetes. It's wreaking havoc with those kind of apps as well. And I'm not using one at the moment, but when I was, that was definitely an issue with other apps that use Bluetooth and trying to use the blood glucose monitor at the same time. It was always quite whack. So I can definitely imagine it's causing some issues.
Right. Next up is new releases for Swift. And this time around, there's an addition for Swift that now Swift Package Manager can use resources. I think this one's actually pretty cool because this opens up the way for all third-party libraries to actually go and use Swift Package Manager. And I'm very excited about that one. It's been too long.
Yeah, let's get rid of CocoaPods.
What about you, Carl? Any comments?
Oh, I've already got rid of CocoaPods. I'm looking forward to this.
Nice.
All right. Awesome. Next up is trailing closures. This one is something that I find very, very interesting. My OCD really likes this. I was actually having this issue in SwiftUI a little bit here and there. That was like, this looks a bit off. I'm looking forward to the new way of writing these trailing closures. All right, moving on. May the 4th. So a new MacBook Pro 13-inch has been released. It wasn't the 14-inch that we all hoped for, but it is definitely a more powerful machine. Yeah. So at some point, I hope that that Apple might still release a 14-inch. I'm sure they will. And then 2 days later, Facebook crashed the whole world. What's up with that?
Oh, it was bad. Hey, we missed it. I think it happened overnight in Sydney, but yeah, that was bad.
I think I got the end of it. So like waking up early in the morning, we still got the end of that issue a little bit.
What crashed for you?
I'm not gonna name apps.
Okay, all
No
right.
no naming and shaming here. But yeah, awesome, right? And next, okay, there was one more thing. I forgot about that. So I went through GitHub to see if there were like a lot of comments on Facebook crashing, and there was heaps of comments. But yeah, this one was one of the funny ones, I think. You know that Facebook's motto is move fast and break things. So this coming out as please move slower and break fewer things was quite funny.
Yeah, especially when those other things are millions of apps.
Exactly.
And crash reporters.
Oh yeah.
And
Yeah,
crash
did you
reporters.
have a slide that Crashlytics went down?
I did not. Sorry, no.
Oh, so good. I think that was the best, like, sort of meta thing that happened out of all of this. The crash reporters crashed. So.
Yeah, it's so funny. Hopefully, it's only a one-off event. Anyway, Apple acquired NextVR. So I hoped last year that Apple was going to release glasses. Unfortunately, that didn't happen. Them buying NextVR is moving into the AR VR space. They're definitely doing something with it. We're just going to have to wait. Hopefully, maybe this dub something gets released. Who knows? We'll only find out. Next up, the release of new watch bands and new watch faces. These ones are actually pretty cool. I've just downloaded the new watch update for the watch and installed one of the new watch faces. It's actually pretty nice to look at. So yeah, yay on Apple for releasing these. Next up, there were some leaks earlier this week. Well, leaks. Someone posted a video on the potential glass leaks. I don't know if it's true, but I guess we'll find out later. And then today, iOS 13.5 was released with exposure notifications. So this includes the new SDK APIs from Apple to talk to COVID, to do the coronavirus tracing. And yeah, I hope that COVIDSafe is eventually going to use this. Speaking of COVIDSafe, I think it's time to go to Richard and his deep dive into the COVIDSafe app. Thank you all for listening to the monthly review.
Okay, I guess everyone can see that now.
Yep.
Cool.
Yeah, perfect.
So the COVIDSafe app was released, I think it was on the 26th of April. At first, I didn't pay a whole lot of attention to it until I started reading quotes from politicians that I thought sounded rather odd. I'd heard previously about Singapore's Trace Together app requiring iOS users to keep the app open, and not having worked with Bluetooth ever before, I just sort of took that as fact that that was what was required. But then we started hearing quotes like, COVIDSafe app needs to be open to work effectively. That was the original text that appeared on the page. Then there was some information around, well, no, to be effective, you have to keep it open in the foreground. Later on at the Senate estimates, Randall's Brugod said, the quality of the Bluetooth connectivity for phones that have the app installed running in the foreground is very good. It progressively deteriorates, and the quality of the connection is not as good as you get to a point where the phone is locked and the app is running in the background. So these kinds of things, these kind of quotes, they really got me interested. I spent all of 5 minutes reading the Apple documentation on this. And it's pretty explicit about background behavior and Bluetooth. So I thought something was fishy was going on here. I'll talk you through my journey about what I did here, what the tools, techniques I used to reverse engineer to find out exactly what was going on. At this point, the source code wasn't released for the app. We had the source code for the OpenTrace code, which the Singapore guys had released. But because there had been some quotes around Australia fixing it, it was really unclear as to what exactly was going on. So as I went through this journey, I also found an exploit, a vulnerability in the Bluetooth implementation that allowed to crash the app via peripheral advertising a malformed Bluetooth advertisement. So let's find out exactly what was going on here. The first tool I usually use, where's my mouse go on? The first tool I usually use when I extract an app off a jailbroken device. So for this, if you want to do this, you want a jailbroken device. There's a jailbreak called CheckRain, which is available for most iOS devices up to the iPhone 10. It'll work on all iOS versions indefinitely. I've got an iPhone 6S here, mirroring on my screen. And that's an iPhone 6S running iOS 13.4.1. So there's a tool called, there's one called Passion Fruit. It's really, really good. It utilizes an amazing tool called Frida, which can dynamically instrument apps, as we'll see in a bit. Passion Fruit recently has a successor called Grapefruit. Functionality is being built into it very rapidly. It's a Node application. You can see it runs this web server. And here we can connect to this iPhone that's connected to my computer via USB. So I've got the original version of COVIDSafe installed on here, as well as the most recent version, and we can sort of compare what's happened. I had to change a bundle identifier of the original one so I could include them both, but rest assured this is the original one. So when we click one of these apps, we can see some basic information about what it's got here. So it shows you where on the device it's installed, where the executable is, the info P list, so you can see exactly the Bluetooth descriptions. We can see here the background mode, so we can see that it wants to use both Bluetooth Central and Bluetooth Peripheral in the background. I might explain quickly what Central and Peripheral are. So with Bluetooth Low Energy, you can there are two different roles, Central and Peripheral. In the Central role, you scan for devices. You basically scan for peripherals, and then you can, when you discover them, you can connect to them. In the Peripheral role, you send out advertisements saying, this is what I am. And if Central comes on and scans it, it'll connect to you. This app does both. That's valid. The Apple documentation says you can do that. And this is saying it wants to do both of these roles in the background. We can also see, using this tool, what kind of URL schemes there are. If it'll open, you can look at all the cookies that are being stored. Keychain, it'll dump your keychain for you. This version is not displaying this in a string format. It's just displaying the raw data. You can look at your user defaults. So, for example, this is what the app stores for the advertisement key, expiry, the broadcast message. Very useful for seeing how it gets updated. You can have a look at like a UI dump, so see how your user interface is being built up. If there's a label, you can see what the actual text is on it, and a lot of things like that. Now, it'll also show us all of the classes in here. So we can see all the classes of the UI view controller. So these are all their names. So you can see how, this gives you a really good idea of how the app is being put together, how it's constructed. There's a log view controller, which sounds quite interesting. We'll get to that later. You can also see what memory addresses these are loaded in at as well, and then view the assembly. So then if you connect to it with LLDB, which we'll also get to, you know exactly where to set breakpoints. And also that comes with this tool is a sort of Finder-like app. So if we go into library, application support, COVIDSafe, this is where the core data SQLite file gets stored. It also has a SQLite browser. So immediately we can see that there's this encounter database table, which has all of the records of the encounters that the COVIDSafe app is recording. So we can see them all here. And this gives us some really good insight into how the app is working. So we can see that it's actually logging when the app is started, when it enters the foreground, when scanning starts, and then also when it does an exchange with another device. It records the model of the central, it records the model of the peripheral, and the message. It also has the signal strength indicator. So that's how they work out exactly how far they think the device is. So given the model of the device and the signal strength, you can sort of inaccurately measure a distance. Originally, they said the app records when you've been in contact with someone for 15 minutes and 1.5 meters. That's not true. The app just records everything, and they work it out later on when they do the contact tracing, exactly how. But they're not releasing the source code for that backend and how exactly the algorithm for how they work out who should be contacted or not. So this is really interesting. This tool gets us a long way without actually touching any code, without any disassembly or anything like that. Now this app, COVIDSafe, it's fairly visually uninteresting. It's just got this spinner, this thing here, that animation. This is the first version. It's been updated since. But and what it does, it just records the context of the SQLite database. But what I wanted to do is, my purpose here was to find out what it was or what it wasn't doing in the background. So first I wanted to verify that the application ran the code that I thought it would. So I'll just open Hopper Disassembler, which is a really nice app for disassembling, decompiling iOS apps. So we'll open up the COVIDSafe binary here that I've extracted off the jailbroken phone. It's a really small app, so it parses and analyzes it really quickly. And what we can search for here is the delegate method of the peripheral that we expect it to run. So if we just search for did discover. So this, in the COVIDSafe central controller, it has this delegate method, did discover peripheral with advertisement data and RSSI. So we'll quickly go in here to the actual method implementation and see where it starts. So this is the memory address of the entry for this delegate method. So the aim here, what I wanted to do was to try and set a breakpoint here and see at what points the app is actually being told that a peripheral has been discovered, at which point it then goes and writes that to the SQLite database. So we'll copy this memory address, put it into our calculator, because we'll need that in a little bit. Let me just, sorry, Zoom is getting in my way. So this is me on I've SSH to the iPhone, as we can see here. And what we'll do is we'll run debug server and we'll connect it to the COVIDSafe app that's running. Then on the local Mac, we'll just run LLDB. Tell it that we want to use platform select remote iOS. Connect to it. Takes a couple of seconds sometimes. But what we need to do, we can't just use that memory address straight up, right? Because what iOS does when it loads an image is it uses something called address space layout randomization. This is a security mechanism to make sure that memory addresses aren't known at runtime. But because we're running it in a debugger, it will just tell us where it's loaded the base images. So it's got a lot of frameworks and dynamic libraries loaded in here. But if we scroll right to the top, it will have the COVIDSafe executable here. So if we copy this memory address, add it to the memory address we want to set a breakpoint for, copy that, and we can set a breakpoint. And then we'll just continue the app running. So right now the app here, the app is paused, the execution is paused, the shield isn't animating. When we run thread continue, we'll see that it's running here again. Now we can see that was quite good. Sometimes it doesn't scan all the time. It has a timer that runs every now and again to do the scan, but we can see immediately that it's hit this breakpoint. We can verify in Hopper that that's exactly what we expected. So STP D9 D8. So this is really good, right? It's doing what we expected. Then what I did after this was put the app into the background, run thread continue. And what I found was that when it's in the background, that delegate method is never called. So I'm not going to sit here for hours and show that to you not being called. But I'll show you another tool that I can use that we can see exactly what's going on here. The other thing I thought that was really handy to do was to see if I could more visually see what was going on. So we'll go back to Frida. Frida lets you write scripts to inject code into applications. So what I had an idea was to try and get it to show local notification when it scans the device, when that delegate method is called. So I'll show you my Frida script here. So this is what it looks like. Frida, you can write in TypeScript, JavaScript. It's really, really bizarre writing Objective-C stuff with JavaScript, but that's the world we live in now. So what we do here is I have this set timeout thing because we need to wait for the app delegate to get called. But we grab the central controller, the COVIDSafe central controller that we saw in Hopper and in Grapefruit. We grab the delegate method, and then we use Frida's interceptor to attach to that delegate method, the implementation of it. When it enters that function, it tells us we can grab the arguments out of it. So we can grab, these are the arguments that are passed to this delegate function. So we get the signal strength, we get the advertisement data, the peripheral information, and the identifier of it. So we try and pull the name out of that. Because it can get messaged so many times, I just have some code here to make sure we don't keep showing the same notification over and over and over again. And then we show the notification and remove it so we can show it again later if it picks it up at a later time. And then in this show notification function, it's just using the standard Objective-C Swift classes to add the notification to the notification center. So to run this, we can go to, where's my directory? We can, so here we've got it. This is the original COVIDSafe app here, where tell Frida to run this notification script, tell it not to stop at startup, and to use a USB connection. So now when we run this, let me just open, let's get the app showing again. When we run this, the app launches, it starts scanning it straight away. And we can see that it's showing us these notifications now. So we've essentially injected notifications into the app so we can visually see what's going on here. Now, when I put the app into the background, we can go and trigger a Bluetooth scan easily by going in here. This is sort of forcing Bluetooth D on the device to run a scan. And we can see it's not doing anything. We can see there are no notifications coming up. So it's a really good indication that the app is not getting, picking up peripheral devices when Bluetooth is scanning. Now, we have the open trace code from Singapore. At this time, we didn't have it for Australia, but what I thought was a bit odd here was that it runs this timer for scanning on the main dispatch queue. And then it fires it off, it repeats it, that's fine. But then it runs central stop scan. Now, the problem with running stop scan is if you run stop scan and then your app goes into the background, all of your timers get paused and this timer never gets a chance to fire again. So this timer is essentially not going to run. So what I wanted to do now is verify that actually nothing had changed in the Australian version of the app. So again, to do that, we can come back to Frida. Frida has a really, really good tool. Let me open the app again because now it's got stuck. Frida has a really good tool called Frida Trace. So again, we'll run it on the COVIDSafe application. And what we want it to do, we want it to, it hooks into any central manager function, core Bluetooth central manager. It hooks into did enter background and this foreground function. So what we can do is use the output of this to see when any central manager functions are being run and when background and foreground, when the app goes into the background and app comes back into the foreground. So if we run this, we'll see it launch the app again. And we can see here that all of these central manager things, peripheral with identifier, the app handles these peripheral with identifier messages, right? But if we put the app into the background, we can see that it did enter background. And at somewhere here, we will see that it stopped scanning. Or we might see a stop scan message coming up very shortly. And if we leave it here for hours and hours and hours, we'll see that that start scan never happened again. So again, this is more evidence that they actually haven't changed this timer code and that basically it seems like there's a bug here that it'll stop scanning and then never start scanning again. So once we can see here, it's entered the background, it's not getting any more peripheral scan messages. Now, so this was starting to show why it not be behaving properly. So I was trying to, at this point, I was trying to say, hey, guys, there's something wrong with the app here. It's not functioning as well as it could in the background. Apple does let you scan in the background. What you have to do is call scan once when your app is open, and then never call stop scan. It will continue, iOS will handle the rest for you. If when it runs a Bluetooth D scan, it will let your app know that peripherals that you're looking for have been found. It was hard to get their attention on this, but eventually the document was sent to them. And the newer version of the app, I actually wrote an example Bluetooth app which pretended to be the COVIDSafe app and showed that it actually worked, could work better than it does in the background. Now, if we run this same script on the new version of the app, let me find it. Let me just kill the old one because they might conflict a bit. If we run this on the new version of the app, we can see that in these trace messages that it never calls stop scan. And if we put the app into the background here, it will continue occasionally to pick up devices. So if I go here, for example, we can see that it's picking up peripheral devices still whilst a Bluetooth D scan is going on somewhere else. So they've actually fixed this. They're doing really, really well here now. They're doing as well as they can without using the exposure, the iOS 13.5 exposure notification APIs. But I think it's a little bit difficult for them to admit this now because they never admitted before that there was something going wrong. So we'll pause here and go on to something else that I found interesting while going through this app. And it's something that you should all consider. So when I was going through the classes that are involved here, that we saw it in Grapefruit earlier, there was that info viewer view controller. So we can see here in Hopper that it's got all of these interesting labels around devices encountered, set obtain Bluetooth state button. So this looks kind of interesting. It looks almost like a debug view, right? So if we go over to the open trace code, we can see here that they've got this same info view controller, but they've compiled it out. So in the production version of the app, you can't, it's the performing of the segue is compiled out. So they've left this info view controller in here, but they don't have the code there. They do have the info view controller in the compiled storyboard lib, which I found. And I noticed that the segue still existed. So at this point, what I thought would be interesting would be to see if I can try and convince this info view controller debug view to show up. So again, we go back to Frida. And I wrote this little script. This is a very, very small script, but to get this working correctly, I really needed to understand how the views were being presented on each other and how to perform the segue that might be there. So first we need to schedule this stuff to run on the main queue. We get the main application, shared application, which I'm sure you've all seen. We grab the root view controller, and actually the way it's structured is that the home view controller that you see with the animation is actually the root view controller. It's actually presenting that view controller modally. And that is the one that contains the segue to the debug segue. So what we do is we grab the root view controller, we get its presented view controller, and then we just try to perform the segue with this identifier. And we give it 7 seconds just to get past the splash screen and present that home view controller. So let's run that one. We've got to run it on the original version of the app as well. Let me just get this showing again. So let's run that. It launches the app. We'll wait about 7 seconds. And here we go. This is the debug view controller that they've hidden inside the app that doesn't actually have code to launch it. But we've used Frida to inject the code to be able to do that. So this is actually a sort of log of the SQLite, all the encounters we could see before. It shows the contacts sorted by the most number of encounters. And it has some settings here. So you can toggle Bluetooth advertising and scanning. It has this obtain Bluetooth state button that doesn't do anything. But I think this is really important for people to understand because everybody these days are doing feature flags, they hide code, everybody commits everything to master and you feature toggle everything as you develop. And that's a really good development pattern, but you've really got to be aware that anything you put inside the app can be found and there'll be ways to access it. So in this instance, I don't think this is such a big deal because the information that it's showing here is sort of the user information anyway. There's nothing terribly, there's nothing scandalous about this information. It's just a debug view and you need to have technical knowledge and understanding of this to get it to show up. But they probably should also understand that this app will come under a lot of scrutiny and this sort of thing will be viewed as maybe unprofessional. And this info viewer was, after I tweeted about it, removed in the next release of the app. It was removed in 1.1. And finally, the last piece I'll talk about is the crash that I managed that we found. So a guy called Jim Musared was doing a lot of research into the way the Bluetooth implementation of this worked, and particularly in the way it worked with interacted with Android devices. And he actually asked me, he said, hey, can you have a look at this line of code and tell me what you think is, if it's doing what I think it's doing. So I had a look at this. We went through this method, and yeah, it seemed to kind of make sense. I walked away, and then I realized, hang on, this looks a little unsafe, because it's trying to get a range of something that it's assuming is at least 2 bytes long. So within, when you're advertising as a Bluetooth peripheral, you can have what's called advertising data. And inside that data, you can put manufacturer data, which is basically anything that you want it to be. It starts off with a company identifier, so the manufacturer. We can see them here. This is a list. They get assigned by these Bluetooth people. For example, if we search for Apple, we can see that it's this. So we can see that it's 2 octets. So really this should be kind of safe, because this should be kind of safe because we expect that there's that identifier within there that's at least 2 octets. Now, so I quickly messaged Jim and I said, look, I think we could cause a crash here if that data can be less than 2 bytes. If it's 0 bytes, it won't get past this. If it's 1 byte, it has to be exactly 1 byte long, essentially. And within 15 minutes, he'd done a little demo with a little Bluetooth device that he could program that managed to crash the app. So how do we do this? What does this look like if manufacturer data has to be 2 bytes? It turns out on iOS and on Android is difficult, very difficult, unless you compiled your own from AOSP. You actually can't set the manufacturer data manually yourself. It's set, that manufacturer is set by Apple, and you can't change it from this. So what I did, I went out and bought a little Bluetooth adapter, $30 from Officeworks. And I wrote some JavaScript, which actually sets that manufacturer data. The way this works, I've got a little slide on it to explain exactly what this should look like. So in your advertising data, the manufacturer data can be made up of multiple elements. So the way this works is the first byte specifies the element length, not including the byte itself. Then the next byte tells you the data type. So FF is saying the upcoming bytes are manufacturer data. And then after that is the actual element data. So this is what it typically looks like if it's got an Apple manufacturer in it. But what if we specified it like this? What if we said, well, the element length is only 2 bytes. We're still doing FF for the manufacturer data, but we're only going to give 1 byte for the element data. It turns out this was enough. This is a valid advertising element. Even though it's not a valid manufacturer, it's still a valid element. So this was enough to actually trigger that range, that fatal error in the range here, because manudata.count was only 1. I don't know how well the video that I'll play over Zoom will work. But this is a sort of demonstration of what happened here. So I had a little server that listened to the API. It had an API that when it hit start, it would start advertising on my peripheral that advertises with that malformed manufacturer identifier. So when I toggle this on, those 3 devices there would start scanning. And as they see that peripheral, they would all just crash. Then when you tried to reopen the app, it would scan immediately and just crash again immediately. I reported this bug to the agency, the government agency that was developing this. They responded really, really well. They responded, I sent them an email at about 10:30 one evening. At 7 o'clock the next morning, they said, hey, we're looking into this. By midday, they said, yeah, we verified that this is an issue. And then they kept me up to date with when they were doing their next release. And once they had it out to users, then I published the findings for everyone to see in it, because I thought it was quite interesting. So yeah, I've covered quite a bit there in quite a short amount of time. We've seen how we can use Grapefruit to do a really, really quick overview, see how an app is structured, how it's put together. We can use Hopper Disassembler to dive much deeper into an application. We can use LLDB and Debug Server to set breakpoints. We can actually use it also to, for example, if you have a method that's returning a Boolean value, for example, is jailbroken, you can then use LLDB to write to the register with the return value of that function to say to say false instead of true, for example. And then through a lot of sort of painstaking analysis, we can find bugs, report them, and get them fixed. I encourage people to use the app. I think there's very few use cases where the app might not be appropriate to use. There are still some privacy issues that have been reported to a lot of governments that are utilizing this method of contact tracing apps where you have central and peripheral. Some have been much more reactive than others on this, but I would recommend to use it. I think they're getting there. They've got the right idea. If you have a Bluetooth device that unlocks your door, maybe get a new door. I wouldn't recommend that at all. But if you have a diabetes machine, yeah, uninstall COVIDSafe. So that's all from me. I hope that was interesting. Give me any feedback, hit me up on Twitter or Slack. And thank you.
That was really awesome. Thanks, Richard. Super interesting stuff. And
Really good. Yep.
Claps all around. Yeah, no, it's been awesome to follow your journey with this on Twitter over the last few weeks. But yeah, if anyone's got any questions for Richard, feel free. Is Twitter probably the best place, Richard?
Yeah, Twitter or Slack will work. Yep.
Yep. You're on the Slack. Yeah, cool. So yeah. Slack or Twitter.
I had the Medium link up there. There's a lot of in-depth posts that I put on there that have a lot more detail on the analysis here and some other commentary if you want to read it.
Awesome. Thank you. Yeah, just some feedback coming through in the Slack now. People saying excellent talk, so good stuff. All right, we're going to move over to Dimitri now for his talk, second talk of the night. So let's get started with that. Over to you, Dimitri.
Yeah, hi guys. Thanks for the great talk, Richard. And yeah, let me share my screen. Is it there? Can everyone see?
Yeah, perfect, mate. That's all good.
Great. That's great. So let me just a sec. Okay. Let's talk about how to avoid damages and shame and regrets, and protect our applications from from different techniques. For example, Richard just showed us. I'm Dmitry. I'm a tech lead in one of medical and security startup in Sydney. And in our application, we utilize a lot of techniques to avoid, to protect against techniques many attackers can apply to your application. So there are around 2 million applications right now in the App Store, and this number continues to grow. And every day we see many and many new applications coming, and all these applications, they work with our data, right? They all somehow interact with us, and they grab our credentials, they grab our personal information, and we need to understand what exactly we store, we allow them to store, and what exactly they store, and how they store it, and how they use this information. Because whatever we give them, potentially this information could leak. And in many applications in the App Store, especially in banking area, in personal emails area, in photos or photo editing tools or social accounts, they interact with our personal information, which is much more sensible. And we will really regret if this information will leak somewhere, right? So how can we be sure that our information and our data is safe? Because over 73% of the most popular applications in the App Store using at least one method to verify or to validate device or to make sure that there is no jailbreak installed. Especially we can find them in banking apps. Many banking apps, they just reject running on the jailbroken devices. But in same time, when we start analyzing more advanced techniques like instrumentation and debugging detection, we can find only 55% and 10% relatively of the applications who use all these techniques. And that's why techniques like in-memory debugging or runtime debugging could allow them to understand the logic of the app, understand different algorithms, entry points, and where all the data is stored and how it could be easily extracted from the app. So, for example, iOS right now fails to secure our applications, and we recently witnessed this kind of things. Just recently, New York Times posted that Jeff Bezos' iPhone was hacked and all information got extracted from it. Then TechCrunch reported that WhatsApp exploit allowed hackers to install spyware. And another news, recent news posted on the internet stated that Palo Alto Networks finds 39 infected applications impacting millions of users. That's a lot. And again, recently we all faced another huge issue with the iOS mail client, which allowed basically attackers to grab your data in case of successful attack. And for this one, they needed only to send a simple email with some malicious payload. So how potentially your phone gets infected? There are many ways, but one of them by installing compromised application from the App Store or third-party locations. So, for example, some company gets hacked, and attackers simply steal their certificate and publish it, update the application with the malicious code to the App Store with their certificate. So you will basically notice nothing, but iOS will automatically pick up the update and done. A little bit harder with the third-party updates when application is distributed from the business account, and for this one you need to install a separate certificate and trust it explicitly. But if you trust it, that allows this company basically install any application with a specified bundle ID on your phone. So again, it could be tempered and with some malicious code and installed on your device. Then another way is visiting an infected website. So this is pretty obvious. So it started with the computers and now spread it to phones. And another way is opening a malicious file like media or document with some malicious payload, which basically runs when you open the app, when you open the document, and it runs and extracts some data or injects some malicious code into the application. So yeah, another one, the one we recently faced with the mail app is receiving a malicious message. And this could be a mail message or any other social messenger message. So, and key factor here is you just need to receive a message. You don't necessarily need to open this. So that means that if you just receive a message. Your iOS device will simply execute certain instructions to process this message, and it is sufficient just to break into your phone and grab data. So let's assume that two mates want to talk about something. Let's say we have Alice and Bob here, and they want to discuss about different things. And here we can say that Alice is your mobile device and Bob is another mobile device, or Alice is mobile device and Bob is some server. And they start sort of communication between them, and they think that everything is safe, everything is so good, and there is nothing to worry about. But here comes Eve. Eve has a very big ears, and this on purpose. So Eve comes to them, and Eve simply starts to listen conversation between Alice and Bob. And in this case, all data these two folks communicate with gets exposed to third party, to the attacker. But Alice and Bob, very smart, they found a safe place, and now Eve cannot hear them anymore. So Eve is very angry, but our Alice and Bob are still feeling safe. But in real life, actually, it's a little bit harder because it's really hard to keep your server in-house or in isolated environment and communicate with no one but yourself. And it's really boring sometimes, but people want to communicate with the entire world, so to interact with a broader community. So let's talk now a bit more about why our applications are not secure and what we can do about it. So the first reason is pretty obvious. It's copy-pasting vulnerable code from different sources. For example, Stack Overflow. Many of us sometimes when we see some challenging task, we don't simply try to design it or spend much time on researching or implementing really robust solution. We just go to the Stack Overflow and grab a couple of links there, and the most rated one we implement in our application. So another one, we are trying to avoid complicated security code. Yes, sometimes security could be very complex and hard to implement, but it pays off eventually. So your brand name could cost it. So it depends on which one has a higher cost here. So another one is debugging and disabling security code and tools. So like we've seen in Richard's presentation, they left one view controller with some debugging information, and they left even segue to this information and to this view controller. So in same way, many developers leave some debugging tools or debugging techniques or like backdoors in their applications for them to simplify debugging in production, for example. This is again another way for attacker to get into the app. So, and what we can do about it? First of all, we need to spend much time on research and find the right tool to protect our applications. So what I mean by proper tools here is something we can trust on, and something we can rely on, something with a bigger name. Another one, what we can do, we can find and implement best practices. For example, there is OWASP website and community, and they have a guideline what and how to protect in the applications or in entire systems. And don't please don't reinvent the wheel. So because whenever you want to re-implement some encryption mechanism, it will probably be error prone and it will contain some bugs, and it might be initially vulnerable. So there are so many existing implementations. There are so many proven and pen tested solutions you can use right away. So there is no need to reinvent everything from scratch. Even it might sound so exciting to implement RSA by yourself. And use your brain, of course. Sometimes you really need to think about what to use, how to use, need to understand the context of the application, context of the user, how they interact with the application, what could potentially leak, and where attacker can potentially find a hole. So again, we need to, first of all, understand what are our potential threat vectors. And by this, I mean how attacker can attempt to get inside to your application, extract some information from your application, and how they can extract data and sensitive information from your application or customers' information. So here is a list of some very popular threat vectors, and one of them is poor cryptography, when cryptography either doesn't rely on secure keys, or keys are very short, and or some other problems with the cryptography. No access control. This is when you allow all users, or you don't specify what user can use what, and sometimes other users might access someone else's information. Authentication bypass. So this is another hole in security where you can somehow, without authentication, access APIs, and those APIs, for example, can expose some data which might lead to personal data leakage. Session hijacking. Mostly used when attacker is able to intercept session or somehow temper it and use this session as and pretend basically as he is the one who created initially a session. Denial of service, and we'll all know about it when you have a huge amount of computers, and they start immediately redirect all the traffic to one particular machine, and this machine is no longer available. And data leakages. So when due to different reasons, you can extract data easily from the application, and many others. Schneier, Bruce Schneier, who actually was one of the famous cryptographer and security specialist in early 20th and 20th century, said that anyone from the most clueless amateur to the best cryptographer can create an algorithm that he himself can't break. And this is true. Sometimes we can create an algorithm and we believe that we believe so hard that it should work, that sometimes we don't want to see that it has some vulnerable places, and it has some vulnerabilities, and other people can actually use them and bypass all your encryption or all your security measures. One big company called Cossack Labs is a security company, pretty big one. So they have a lot of products related with the security, and they released a couple of diagrams for Android and iOS developers, and they suggest at least follow several steps to understand what kind of encryption you can use, or what kind of security measures you can use in your application to make it more secure, make it more reliable in terms of not leaking sensitive information. And for example, you have application which works with some sensitive information, but you don't know how to protect it. And here we can consider ourselves as a usual, let's say, iOS developers, and our choice as a third step here could be either REncryptor, it's another good library, or Lipsodium, or you see some other libraries over here. And after this, what we need to do, we need just to somehow explain this to the user in some sort of documentation, how we use this data and how we protect this data. And eventually, yes, your job is done. So your application now is more secure, and you don't have to worry much about this anymore if you properly implemented it, of course. So who can we trust in this area? What kind of frameworks, what kind of libraries out there we can trust? Because we can find so many of them, and there are so many of these kind of libraries implemented by guys who just wanted to try their exercise their academical skills, and they want to pass some document or create some artifact in the internet, and they just implement their own RSA or another algorithm, encryption algorithm. So we need to find a way how we can trust them. So definitely we need to pay attention to their scientific background. So if they have something with a mathematics background or security background, it's a huge bonus. So well-known brands, so obviously, so if you already know about them or heard something good about them, it's a big plus to them. And great track record. So that means that probably if you call yourself a security specialist or security company who do pen testing, so you shouldn't have any sort of leakages in your past, or you shouldn't have any sort of bad reputation in the past. And here is an example of some well-known libraries you can easily integrate in your application and increase security of your application significantly. And we, for instance, use several of them. We use Lipsodium, we use REncryptor, and partly Signal protocol. So I would highly recommend to check all of them and find your favorite one. So what we protect? We protect customers' data, we protect our users' data. And this data has several states. It's sometimes located in memory. Sometimes it is in transition between two different devices, and sometimes it is already stored in our device and we need to do something about it. So protecting data in memory. So mostly it is all about checking for jailbreaks. And to check your application, if it is running on the jailbroken device, you need to do several checks. And first one could be checking for different files already exposed to your application. So on non-jailbroken device, you probably won't be able to access this list of files. And or maybe you can access on jailbroken device, some of the files don't exist. So you need to really, your check should be really extensive and check as many as possible files. So in this, for example, JSON file, there are more than 40 files, I believe, to check, and at least one of them will be on jailbroken device. Then you need to check your sandbox, if it is corrupted or not, by checking such functions as a fork, system key, popen, and others. Then you probably want to check Cydia URL scheme. Cydia is another store where you can download different tweaks and applications for your jailbroken device. Then you might check your file system permissions if you can access your root folder or private subfolders or any other of the listed folders. That means that probably your device is jailbroken. Then debugger detection. It's a good practice to disable debug detection to do not allow attacker to analyze the behavior of your application. So basically, they won't be allowed to connect debugger and change any values, bypass your jailbreak checks, or do some kind of injections. And runtime modifications. This is the trickiest one, I believe, because it's harder to protect from this one, but it gives the most results. This is basically protects the application from tampering. When attacker can inject some code into your application and the application wouldn't even know about it, it will just simply execute it and like its own and without any suspicion. But if you protect with checksums validation, if you protect with the dynamic link inspection, then you will definitely increase the complexity for attacker to tamper your application. Then how we can protect our applications when they are in transit. So that means that when you're sending some customers' data to your server, or you exchange some information between two different devices. So first of all, we know that on iOS devices, we have ATC, Apple Transport Security settings. So I encourage everyone to check them and disable backward compatibility if possible, because they found multiple vulnerabilities in previous TCP and SSL versions, security vulnerabilities. So it's better disable it, because if you won't disable it, your device attacker might request to lower down the protocol version, and it will be vulnerable. It become vulnerable. Another one, use long keys. So whenever you communicate with another device with SSL, so there is an option to use long keys or short keys. So I would encourage everyone to use longer keys. SSL pinning, probably everyone heard about it, but it's a big topic and there are pros and cons about it. So Google recently recommended to do not use SSL pinning because it involves some level of maintenance on your application and certificates. SSL pinning, maybe for someone who never faced with this term, means that when you establish connection with your server sends you a certificate he wants to communicate with, and you if you want you can basically validate the certificate and try to understand if this is really your server's certificate, and if this certificate is still valid, or maybe someone is sitting between you and this certificate, this server listens the traffic, and they just switch the certificate from your server with their own, so you can trust them and send all the traffic. So your application might think that everything is encrypted, everything all right, but apparently it's not. So SSL pinning, basically another check that certificate is exactly the one that was issued for your server. It's not expired, and it's still validated with the root authority. If you don't want to do SSL pinning, you can still do at least certificate validation. So when you receive a certificate from your server, you can still ask iOS to validate security chain, how they call it, signature chain, and validate that this certificate is assigned by root authority. Then use strong ciphers. So these days, it is recommended to switch more to elliptic curve encryption versus RSA. And because there are some vulnerable points were found recently in RSA, and it's a little bit slower. So that's why it is recommended to switch more to elliptic curve encryption. And again, proper app transport security configuration. Please remove all the allow arbitrary loads from this settings if you obviously not developing something like a web browser, which obviously should access everything. But even in this case, Apple recommends recently added another flag like allow arbitrary loads only for web content. So application itself shouldn't allow access to some random websites. Another one, when you want to protect your data in transit, is forward secrecy. Forward secrecy is a technique when you encrypt your data additionally and send it over HTTPS channel. But in order to encrypt it, so there are multiple techniques. You can use symmetric encryption, asymmetric encryption, and different length of the keys. So what will be the good option is to use ephemeral keys. That means that those keys are derived from some master key, but they're changing over time. That means that not changing over time, that's key rotation. That's another point here. And both techniques are basically allows you to generate some random keys based on some master key, and allow these keys live quite short time. So for example, in different messengers, they implemented the 1 key per message. So some time ago in Instagram, not Instagram, WhatsApp, they used the 1 key per message. In Signal, they also use 1 key per message. And but there is another problem comes here. Well, what should you do to negotiate all these keys? How you should exchange all these keys? And then this is another big topic. But in this case, definitely if you use ephemeral keys and keys rotation, when you constantly regenerating these keys and you constantly re-encrypt this traffic, even someone intercepts portion of your traffic and they will try to decrypt it, they might have an access only to very, very small portion of data. So if you rotate your keys, let's say every day, they can have an access only for 1 day of data. So later, everything before and after will be encrypted with other keys. And protecting your data at rest. So when your data is already on user's device, you need to also somehow care about it, because with a simple file manager or with a jailbroken device, it's easy to browse the entire file system and grab SQL-like database, all the configuration files, cache, whatever, cookies. So for this purpose, we can use different attributes for data file protection and for keychain data protection, including when unlocked, locked, when after first unlock, and always. So I wouldn't recommend to use always. So better to think how you can fit with when unlocked, or completely unlocked, or after first unlock. But it's more it's more about your user experience, and you need to find the right balance between right proper security level and right UX in your application. And for example, in Realm database, they have encryption embedded right into their database. So when you provide the encryption key, when you instantiate the instance of the class and you pass it in your configuration, you pass basically 64 bits encryption key. They encrypt the entire database on the fly. So when you commit something to the database, it gets encrypted and stored into database in encrypted. And when you run a query and get some data from database, it gets decrypted from database and passed to yourself. So they say that it's additional like less than 10% overhead on CPU. So it's nothing, I think, compared to really good encrypted storage. And key management. So this is another big topic. So you created these keys, right? So you created the key for your local storage, you created master key for your keys rotation mechanism and for forward secrecy, but where to keep this master key or your data storage key? Apple says that you should store it in a keychain, but apparently keychain sometimes could also be exposed and used by attacker to grab some data, or maybe attacker can get access to your keychain from another application, vulnerable application, but you can store your data there. So be aware of this kind of way of thinking. And so whenever you store something in your keychain, also sometimes needs to be encrypted, or simply don't store anything there, store it on your server, which basically allows only authenticated users to access it. And all your keys basically should have proper key derivation function, because whenever we get some password from a user, we shouldn't just rely on this password because it might be not that secure. Some bits might be predictable, and it will be easier to guess the password. It will be easier to guess all the bytes if they have some bytes from the password. So that's why in many cryptography frameworks, they have key derivation functions. So if you use one of them, they will produce proper keys with the proper length and proper encryption standard. And now with all these techniques, we can say that Alice is more secure. They use SSL pinning to check the data in transit is secured. They use ephemeral keys to guarantee that no data could be exposed. Even SSL wouldn't work, and no data gets leaked, even if some portion of data decrypted or leaked. And I mean, no other data is leaked. And encrypted storage allows not allows attacker to access it when it is already stored on device. And Bob is also feels much more secure, because on the service side, we also use ephemeral keys and keys rotation to add additional layer of encryption on our transmission channel, and they also use encrypted storage. And like in many databases, on database level, we can, on the backend side, we can turn it on, and all our data will be automatically encrypted and stored already in encrypted way. And Eve feels a little bit upset because it becomes much more harder now to listen what Alice and Bob are talking about. So overall, yes, we can protect our customers' data, and we can do this with several simple steps. First of all, we need to check our HTTPS settings, and we need to make sure that it contains only latest protocol, or at least not vulnerable protocol, and it doesn't have allow arbitrary downloads or uploads. Flag set, then SSL pinning, or at least validation, is set. Then we need to check that encryption data is implemented properly with forward secrecy, and stored data is also encrypted, that hacker cannot access our data when application is not running. We need to properly protect our encryption keys, either storing on server or at least in keychain in some kind of also hashed on encrypted way. And we obviously need to check for jailbreaks, and in several ways, obviously, in several different places in our application, and in several different ways how we check, and not only check that we can escape from the sandbox, but utilize all these different techniques I listed before. And definitely use runtime tools checking to do not allow debugger to attach, or to do not allow injecting third-party code into our application. If you want to get a little bit more information about all these techniques and how attacker can potentially get inside your application and steal all the data, here are some resources. First one, I would recommend Mobile Application Hackers Handbook. And another one is written by Apple. This is Designing Secure User Interfaces. Quite interesting reading. CryptoCat iOS application is another application which was written in such a way that the entire code base could be explored. So you can check the code, you can see this, and it was pen tested by several companies, I believe. And this is an example where having code means nothing, so you can still access users' data. Storing secret keys, how potentially you can store them, and what are the ways, and how you can avoid leakages of those keys. And there is another really great book on the internet, Hacking and Securing iOS Applications by Jonathan Zdrasky, I believe. And this book is about many techniques, but one of them specifically is about how to avoid code injection and how to avoid debug tracing in your applications. Thank you. You can download this presentation from this link. And if you have any questions, I'm happy to answer.
Cool. Thanks for that, Dimitri. That was awesome. We've got one question in Slack. There's actually been some really interesting discussion going throughout the talk about things you mentioned. So I'll leave that for you to catch up with in your own time. But Carl's got a question. Is it worth protecting from jailbroken devices?
It depends. So it depends. So I would also always recommend to protect from jailbroken device, because it's just a common sense. Like, why would someone need to have a jailbroken device these days? Previously, yes, of course, it might be really useful because you might want to install different UI tools, something Apple doesn't want to release. But these days, honestly, jailbroken devices are used only by security specialists or attackers. Or yeah, like in CryptoCat, you can design all your application in such a way that it gives no information to your attacker about your users. So it basically uses either end-to-end encryption or something like that. So basically all the information is properly stored.
Cool. Yeah, awesome. No, thanks heaps for that talk. If anyone's got any more questions for Dimitri, he's available in Slack. I'm sure he'll be happy to answer them for you there. All right. Well, thanks everyone for attending our second remote meetup. I think it went well. There were some really great talks. So thanks again to both Dimitri and Richard. Really appreciate it. Nikki's had to run, but on behalf of Carl and myself, thank you everyone for attending. We're going to have a small Zoom call just after this. So I'll be posting the link to that once it's up and running in the Meetup channel on Slack. But otherwise, hope to see everyone again next month. And if you're at all interested in giving a talk or you'd like to work through some ideas, please let me know and we can make that happen. So thanks everyone. Have a great month and we'll see you in 4 weeks.